So two fractions are considered to be equivalent fractions if they have the same value. So equivalent, I mean, if you break down the word itself, it literally means equal value. That's what equivalent means. So we've got two examples to show you. Show that 2/3 and 4/6 are equivalent using an area model. So because it's an area model, you have to draw two-dimensional shapes, and I think rectangles are the easiest. So if we want to show that they're equivalent, one of them is in the language of thirds, the other one is in the language of sixths. And you can see that the rectangles that I've drawn to start with are the same size, because when you're comparing, you want the holes to be the same size. And I cut the top one into thirds, and I cut the bottom one into sixths, because we have the language of thirds and sixths. So that means that each one of these is worth a third. And on the second picture, each one of those little parts is equal to 1/6. And so you can see that you have 3/3, that equals 1, and 6/6, which equals 1. So what they want us to do is they want us to show that that 2/3 and 4/6 are equivalent. So let's draw what 2/3 would look like. Well, 2/3, if I shade it, would be this much, right? It would be like this part. That's 2/3. If I shade 4/6, so I'm going to shade 4 of these sixths. That's hard to say for whatever reason. So this is 4/6. You can see that they're actually the exact same length. So because those shapes are the same, I'll put in here, same length, that proves that 2/3 and 4/6 are actually equivalent fractions, because when you draw them with an area model, you get the same length. If you want to do this on a number line, it's super similar. So I just slightly changed the numbers here, but it's kind of the same idea. It's just kind of a single dimension. You don't have to draw rectangles. So show that 3/4 and 6/8 are equivalent using a number line. So that means I need to cut this into fourths, but I also need to cut it into eighths. And I have found, I think the easiest thing to do would be if we do like fourths on the top maybe and eighths on the bottom. So I've got from 0 to 1. If I want to show 3/4, then I have to cut this into fourths. So I'm going to attempt to cut it in half, and then cut each of those little halves in half. And I'm going to do fourths on the top. Going this way. So we have 0/4, and then we would have 1/4 and 2/4 and 3/4 and then 4/4, right? So we're like translating to fourths language. And I'm going to play the same game, but I'm going to do eighths, and I'm going to do them underneath. So we know it's 0/8, but to get eighths, you have to cut each of your fourths in half. And then you've got to count to 8. So you've got 1/8, 1/4, which is the same thing as 2/8, 3/8, 4/8, 5/8. See, if you're just very systematic about it, it's not so bad. So like that. And we're going to show that 3/4 and 6/8 are equivalent. So on the fourths side of things, here's 3/4, it's right there. And you can see what's located in exactly the same spot, 6/8. And so that picture shows that 3/4 and 6/8 are equivalent fractions.